I'm a solutions architect with Google Cloud. And to start off with, I'm going to talk about what a data lake is, how you would structure your data lake on GCP with a lot of help from BigQuery. And then after that, Dhaval Durve over there, who is a strategic cloud engineer with Google Cloud, will talk about how you would operationalize BigQuery. And then lastly, Tomak Stradomsky, who is also over there, will go into detail about how Ocado technology, by the way, Tomak leads up data engineering at Ocado. He'll talk about how Ocado built out a data lake with a lot of help, once again, from BigQuery. I know we don't have everybody in the room, but I'm going to do a quick informal survey. So by a show of hands, how many of you here have either built out a data lake already or are thinking about building out a data lake? Okay, I'm not surprised. That's good. So this term, data lake, is thrown out a lot. It has a lot of meanings to a lot of different people. What I'd like to do first is do some level setting on what I mean by data lake for the purposes of this session. And I think you'll agree with most of these characteristics. The first one is this philosophy of storing everything. And what that recognizes is the fact that we want to guide the questions we're asking of our data based on the data that we can collect. We want to collect everything, of course, within compliance restrictions and storage restrictions. But yes, we do want to collect everything. And once we collect the data, our data lake has to facilitate exploration. That's how we go from raw data to refined data products that will inform us, whether it's about business decisions, new opportunities, operational efficiencies, things of that nature. And once we surface these data products, we want to be able to bring a variety of tools to process these data products. Of course, this session's about BigQuery, so it'll feature prominently in how you do analytics. But in addition, we want to be able to allow our data scientists to use Spark, MapReduce, Cloud Dataflow, which is our serverless processing engine, all of these tools. So with those characteristics in mind, here's a high-level flow of how things go from raw data to the refined data products. And this will be kind of a theme, at least during my presentation. On this slide, we're going to focus on the ingest and store piece. We ingest data from a variety of sources. We want to facilitate batch analytics as well as stream analytics. And when it comes time to store the data, I'm going to say right off the bat that Google Cloud Storage, also known as GCS, is the ideal choice for the lake itself. And you're probably wondering, hey, this is a session on BigQuery. Why is he talking about GCS? And that's because, and by the way, when Tomak goes into detail over how they built out their data lake, you'll hear that they're ingesting structured data, storing it directly in BigQuery, and doing analytics with BigQuery. And that's great. We love that. Two things to keep in mind. The first one is that as your data volume grows, as you go from hundreds of terabytes to, say, many, many petabytes of data, it makes financial sense to lifecycle your older data from BigQuery into one of the archival storage classes that GCS has. This way you can balance cost as well as analytics capability. And then the other reason is that you want to be able to do the flexible processing that I talked about. SQL is great, but once again, you want to bring in Spark, you want to bring in MapReduce, you want to do predictive analytics. And for that, GCS is great. It's a great central repository that integrates well with GCS services, as you'll find out, as well as a whole slew of third-party services. And I mentioned, working well with GCS, and BigQuery, as you would expect, works really well with GCS as well. For example, if you have Avro files in GCS, you can query those files, with rich schema and all of that good stuff directly from BigQuery without first loading that data into BigQuery. Now, having said that, for the vast majority of use cases, you actually want to pull that data into BigQuery first, because it gives you better performance, it gives you more native querying capability. And you'll be happy to find out that import and export to and from GCS into BigQuery is free. And the last reason to use BigQuery in combination with GCS is that they share a compatible security model. They both use GCP identity and access management. This has ramifications for how you do access control, as you'll find out from Double, and encryption as well. So if you have a compliance regime that requires you to use customer-managed encryption keys, then you can use those same keys for encrypting and decrypting data in both GCS and BigQuery. So we talked about ingest. Let's get into the other two characteristics that I talked about. There's a lot going on in this slide, so I'm going to unpack it into smaller, digestible pieces. And once again, the question that's going to guide that is, how do we get from all this raw data that I talked about to the refined data products? To answer that question, let's break those refined data products into three categories. These are categories that I feel will help us guide this discussion. So the first one is this notion of a data mart. This should be familiar to folks who use SQL data warehousing, but I want to expand that definition a little bit, even though this is the thing that BigQuery is best known for, SQL data warehousing, setting up data marts. But a lot of customers these days are also doing Parquet files, Avro files, and refining data in that fashion and exposing them to both internal and external customers. If you do that, you can use Hive, you can use MapReduce, you can use Spark on top of those files as well. And you can also use serverless processing with Cloud Dataflow. The second type of data product is streaming workflows. So, if you have a retail e-commerce website and you want to better understand, inventory depletion, how customers are navigating your site, you could set up clickstream, capture, send that to Cloud PubSub, which is our global messaging service, and then you could use Cloud Dataflow to grab messages out of PubSub and then use BigQuery streaming API to ingest that data directly into BigQuery. And what that lets you do is, with very low latency, query that data. We're talking a matter of a few seconds. This is pretty powerful, and once again, BigQuery excels at this. And the last type of data product is predictive models. So whether it's statistical models, machine learning models, you could look at the captured raw data, figure out what kind of trends are in there, and set up a TensorFlow model, and then import that model into Cloud Machine Learning Engine, which is our serverless machine learning framework, and train that with all the training data you've captured using GPUs, TPUs, and then deploy that trained model into Cloud Machine Learning Engine once again, and do inference. So those are the three types of data products. One thing I skipped is how you do mining and exploration in between. So, taking all that raw data and coming up with data products, that's in keeping with our philosophy of letting the data guide the types of questions we're going to ask. And this has to be an iterative process. We're not going to be kind of rigid in the types of schemas that we will expose to our analysts. In order to do that, you need an agile, nimble, way of doing things. And this is where BigQuery, once again, can help a lot. So without having to put a lot of thought into the type of schemas that your raw data has, you could load that into BigQuery, set up a BigQuery data set, and then your data scientists could figure out, hey, what are the types of trends that this data has? How can we surface more production-ready schemas in our data marts? What type of streaming workflows can we set up? And then also do trend analysis to figure out the kinds of predictive models we can set up. So to wrap things up for my piece, I'd like to go over an example that kind of captures all of this and also includes orchestration. So let's say you have a data lake that has to pull in a lot of unstructured data. This is in contrast to something you'll hear about from Tomac. So let's say you have videos, images, speech data. This is something that has been opaque up until very recently. So what you can do now is send these types of files into one of our serverless machine learning APIs, extract meaningful metadata. So if you have a whole bunch of cat videos, You can send that through our video intelligence API, figure out what types of objects are in those videos, what they're doing, store that metadata in BigQuery, along with links to the actual files themselves. And orchestration is a key piece here, because you're pulling in data on a daily basis, and you have to orchestrate it so that metadata magically appears in a system like BigQuery. So Cloud Composer, which is our managed Apache Airflow service, is a great tool to use here. Cool, so with all of that said, let's hear from Dhaval about how you would operationalize BigQuery on GCP.
Thank you, Karthi. Good morning, everyone. Welcome to Google Cloud Next. My name is Dhaval Durve, and I'm a strategic cloud engineer in Google's cloud team. So far we have talked about how BigQuery can be used to explore your data in a lake. Now let's take one step further. Let's try to create a data mart or data warehouse in BigQuery and walk through the process for that. So how do we operationalize that? Now, first thing in operationalization is how do you ingest your workflows, or how do you build your ingestion pipelines? With BigQuery, depending on your needs, you have many choices there. If you want to really write simple workflows, just loading data files, you can use BQ command line tool for that. If you want to do some kind of transformations, but don't want to do any coding, you can use Cloud Data Prep, which is an excellent tool to do that. For more complex transformations or more flexibility, you should use Cloud Data Flow. Now, first three options that I have mentioned are mainly used to ingest data from either your batch files or either your middleware systems like Kafka or Cloud PubSub. If you want to directly ingest from your application itself, BigQuery provides you a streaming API which can be used to directly ingest data from your application to BigQuery. These records which are ingested are also available in near real time for your users to query. So these are some ways how you can ingest your data in BigQuery. Now the data is ingested. So natural next stop is to talk about access control. BigQuery takes a really simple approach over here. You can add resources at organization level, project level, or dataset level with BigQuery. All of your permissions inherit from top to bottom. So if you add somebody an admin at organization level, they'll automatically be added to all of your projects and all of your datasets. On the right-hand side, you are seeing type of entities that can be added to BigQuery. So first three options over there, users, groups, and domains, can be added to any of these three levels. Public and authorized views are only available at dataset level. If you make any dataset public, that becomes available to any GCP user in the world. So this option is available when you want to open source your data or just make it available for everyone to consume. Authorized views basically give you an option to provide more granular controls over how your users access data. So if you want to go beyond dataset level, you want to apply table level or row level access, you can use authorized views for that. So now you have set up access. How do your users get started? So once your data is ingested, good thing with BigQuery is you don't need to do any kind of tune-up, any kind of indexing or sizing up your environment. You can basically get started just after ingesting your data. What your admins and your DBAs can actually do to help your users out is go to BigQuery console, write some sample queries for users, save them, which will be shared across all of your users in the project. You can make them private as well, but sharing them will start your analysis much faster. Also, BigQuery supports standard SQL, which is compliant with SQL 2011. So as long as your users know SQL, they're good to go. Now, some of the organizations have these central teams whose job is to manage these curated data sets. And all other teams or other cost centers usually query those data and create their own data set on top of that. Now, with BigQuery, you get charged for storage separately and compute separately. And you want to make sure that your storage costs, your central group doesn't get charged for querying by other users or other analysts or other cost centers. What you can do is, with BigQuery, create a central project which will keep these curated data sets, create separate projects for your cost centers, and they should use different billing accounts so that whatever querying cost they incur, they goes to their billing accounts. And your central group just pays for your storage costs. Also, Karthi just mentioned how you can explore your data using BigQuery and Data Lab, but it also provides a lot of connectors for tools like Tableau, Looker, and Data Studio to visualize your data or run your reporting workloads on top of it. Now your users are consuming this data, so your admins need to monitor your environment. BigQuery provides a lot of metrics in Stackdriver itself to look at the health of your environment. I have mentioned some of these over here, which can be used by your billing admins, your storage admins, or any kind of resource admins to look at how your environment is doing. They can also set up alerts and notifications on these metrics so that whenever the value of any metric goes above or below their threshold, they can get notified for that. Let's talk about compliance. So from an auditing perspective, BigQuery provides mainly two types of logs: admin activity and data access activity. Admin activity keeps information about schema changes, schema creation, data set creation, table creation, etc. These logs are available for 400 days. Data access activity logs are available for 30 days, and that keeps information about who is accessing what kind of data or what kind of data is getting modified. If you have a need and you want to change how many days the data gets retented, what you can do is you can export these logs into Google Cloud Storage or BigQuery itself, and you can set your custom duration over there. If you want to look at these logs on a real-time basis, you can always stream these logs into Cloud PubSub and attach your application to Cloud PubSub to be able to do that. Now your users are using it, your admins are monitoring it, so of course they'll find new use case patterns and new information that they did not know when they built it. So how do you optimize based on what you know? So when it comes to optimization with BigQuery, there are three major areas which I would like to cover: storage, cost, and compute. With storage, so a lot of data warehouses have SLAs to keep data for X number of days. That could be 100 days, 200 days, 300 days, whatever. And after that, team has to remove that data either by building it in process or doing it manually. With BigQuery, what you can do is you can actually set expiration time for any data set, table, or partition, and BigQuery will automatically remove that data and clear up a storage for you. From a cost perspective, one thing I say is if you have already loaded data in BigQuery and you are not modifying it, just keep it in BigQuery. Because if you keep that data in BigQuery, either BigQuery table or partition for 90 days and don't change it for 90 days, BigQuery automatically charges you much less for its storage cost because it considers it as a long-term storage. Again, you don't need to do anything. It just stays there, and you'll get charged much less compared to how you will get charged for active storage. Also, try to use partition tables, because whenever you are using partition tables and you use right filters with BigQuery, you scan much less number of bytes, and you get charged much less compared to scanning entire table. Also, sometimes you don't know how big the table is, and you want to just get a feel of how much your query will cost. Before running a query, you can actually schedule a dry run for query, and that way BigQuery will give you some estimate about how much it's going to cost you. It's a good way for you to just try before buying it. Also, if you are running same query again and again, and I see that happening a lot in your reporting workloads, BigQuery tries to read that information from cache, and you don't get charged for reading data from cache. So BigQuery tries to do it on its own. Now, sometimes you have users who are new to BigQuery or new to organization, and you really don't know how they are going to work with BigQuery. And as this is a pay-as-you-go, your charges get goes up as soon as they start using it. And you want to make sure you want to control how much data they access or how much cost they incur on a daily basis. You can set custom quota in BigQuery UI itself for any particular user or any particular project, and that way they will never blow up your budget or they will never go out of the cost that you have decided for them to use. Now from compute side, I always say start optimizing your queries, make sure you use the right queries. And what I mean by that is BigQuery is a columnar database. So that being said, don't try to use select star with that. Try to use only those columns which you need for your aggregation or any kind of queries. Try to use partition tables and write partition filters with that. Also try to denormalize tables whenever you can, because cost of denormalization and storage is much less compared to cost of join. Also, as you might know, BigQuery usually charges for pay-as-you-go. That's the by default option. And what I mean by that is, whenever you create any project, by default, you get up to 2,000 slots. And what I mean by slots is, you can think of slot as a computing unit that you get with BigQuery. You get up to 2,000 computing cores or computing units with BigQuery by default for your project. So what happens is, if you are running one query, we can take up to 2,000 slots. If you are running multiple queries, that can also take up to 2,000 slots. So if you have more important queries and less important queries in same project, what you can do is you can actually set those less important queries and run them as batch queries. That way they'll get deprioritized. They will still finish, but they will get deprioritized, and your actually important query, which have strict SLAs, will run first. Now, you might be coming from some large organizations, and you might have very large analytics workloads. In that scenario, you can go to the second option that I have mentioned, which is fixed slots. A lot of the organizations have like very high analytics workloads, and they can actually come to us and buy additional number of fixed slots. So by default, you get 2,000, but you can buy up to any number, and that will be a fixed number of slots for your organization or your project. With fixed number of slots, it also controls the cost in a way that you always know how much your monthly compute cost is going to be with BigQuery. So because once you buy a fixed number of slots, there is no pay as you go. You can run any number of queries, and you'll still get billed for same how many slots you have purchased. Also, one option which becomes available, and we call it hierarchical slots, is something that comes with fixed slots. And I'm going to give you an example of it in next slide. So let's assume you have 4 projects: R&D, dashboards, ETL, and ad hoc. Bottom 3 projects are important projects. They have strict SLAs. You want to make sure they finish on time. All the jobs for them finish on time. Ad hoc project is mainly a playground area or sandbox for your new users, where they just want to try things. You don't want to incur any additional cost for that ad hoc projects. If you buy fixed number of slots, what you can do is you can configure this top project, ad hoc project, in a way that it uses resources only when they are available on bottom 3 projects. So any of the projects below have any slots available, this ad hoc project can take those slots from those projects and start using those resources. So that way you can share or prioritize or deprioritize your projects as well in BigQuery. But you need to have fixed number of slots for that. So these are some ways you can optimize your cost or storage or compute in BigQuery. Now, before I ask Tomek to come on stage and present his Ocado case, I'm just going to summarize what we have discussed so far. So as Karthi mentioned, BigQuery works seamlessly with data lake. You can explore your data. You can do mining and exploration right over there. Once you have built your data mart, you can centrally manage your resources through identity and access management, and you can monitor them using Stackdriver. When it comes to flexibility and compute needs, BigQuery gives you a really great flexibility regarding what you want to do when. So if you need more compute, you can buy additional number of fixed slots. If you just need more storage, just keep your default option, and you'll be fine. Last thing I wanted to mention was you can always share with BigQuery, and the way it works, you can always share and collaborate your data, compute, as well as your queries across your users in your organization very seamlessly. That being said, I'm going to ask Tomek to come on stage and present how Ocado is using BigQuery. Also, one announcement I wanted to make is this session is Dory enabled, which is our live questions platform. So you can go on your app, and if you have any questions, you can put those questions in this session's questionnaires. Thank you so much.
Thanks, Dhaval. Good morning, everyone, and thanks for coming. My name is Tomek Stradomski. I'm leading data engineering at Ocado. You have heard quite a lot of useful information about products that are available in Google Cloud Platform and how you can use them to store and analyze your data. Now I would like to tell you how in Ocado we combine those components together to build our data lake. Not sure if you have heard about Ocado before, but let just me quickly introduce to you what we are doing. So we are the world's largest online-only supermarket. We deliver more or less 50,000 of products to more than 600,000 of active customers in UK. But what is important, we build our solution in-house. For example, robotics in our warehouses, front-end application, back-end systems, everything. The heart of Ocado are highly automated warehouses, which we call CFC, Customer Fulfillment Center. So you can imagine that on the grid of size of football field, there are hundreds of bots moving, carrying some products, doing some operations just to fulfill orders of our customers. But Ocado is not only CFC. we created e-commerce end-to-end solution. That, of course, includes delivery systems, customer center systems, so basically everything we needed to succeed in this business. As you can imagine, we collect quite a lot of data from those systems, and we use them to leverage our business. So, for example, we have recommendation systems, fraud detection, automatic classification of emails that is using deep learning. But this is just half of our story. So on one side, Ocado is the online supermarket. But on the other side, let's for a second imagine that you are a traditional retailer and you would like to go online. This opportunity is called Ocado Smart Platform. So the idea is that we are selling our technology as a service. At the moment, we have a pleasure to work with several retailers in Europe and North America. To be able to start new environments for new retailers, we moved our solution to cloud. And the process of moving to cloud gave us quite unique opportunity to rethink and redesign our systems. And that also includes data architecture. So before moving to cloud, we've been working with some on-prem solution like Oracle, Greenplum, different on-prem file storages. And it's a challenge because you need to plan your capacity. What data is most important for you, what to do if you are running out of storage, how to implement your retention policy. So we didn't want to care about that anymore. So we wanted to build a solution that is able to store all the data we need. Secondly, we wanted to have the data processing so easy that everyone in organization can do it. In most of organizations, there are some dedicated data teams like big data, data engineering, machine learning teams. We, of course, also have such teams, but they are mostly working on toolkits, best practices, and enablement. And the idea is that we would like to enable everyone in the organization to be able to process the data. And to do that, you need really simple and coherent solution. So we ran a couple of proof of concept, and at some point we tested BigQuery. You have heard quite a lot about BigQuery, but let me just quickly tell you what was important to us. So first of all, it's extremely easy to use. You don't need to worry about DB tuning, so you don't need to maintain indexes, materialized views, hundreds of parameters, tune, memory structures, storage structures. You just load your data and you can query it. In BigQuery, you pay for two things, for storage and for querying your data, and it depends on the volume of data your queries are scanning. But it's quite transparent. You have good control over it. It's easy to enable your billings, and there are some things you can do to reduce the cost of using the solution, and it has been covered by Dhaval. It works quite well with Google Cloud Storage. So basically, if you have a lot of unstructured data, it's probably a good idea to store it on Google Cloud Storage. But there are some products that you can use in Google Cloud to extract structured information and store it in BigQuery. In general, we don't have a lot of unstructured data, so we are storing everything in BigQuery. So this is our main data lake solution. Maybe the most important part, it scales endless. So basically, you can imagine that under the hood, you have the processing power of Google data centers with Borg grid computation, Colossus file system, Jupyter network. So almost no way to exhaust those resources. And the last thing, quite important to us, is data locality. We, at the moment, operate mostly in EU. That's why we wanted to have our data stored in EU. And this is something that BigQuery gives you out of the box. You can choose the location. It can be US, Europe, Asia, whatever you need. So we decided that BigQuery is going to be the brain of our data lake, but we needed a simple approach of loading the data into BigQuery. And we tried event sourcing. So just to remind you, our applications are running in the cloud, and we use microservices architecture. So those microservices are doing some business operations, and that, of course, generates some data. So idea is that we pack this data into event and send it to the cloud. So for example, customer makes an order. There is an event sent. The order is picked or delivered. There is an event sent. The payment is taken from the account. Event sent. And all those events are sent to the stream in cloud. We use Kinesis at the moment. Now, you may ask why we are not using PubSub from Google. And that's because when we started working on this architecture, PubSub was not available at all. OK, so all our events are sent to the stream in the cloud. And from there, we stream it into BigQuery. So we created a real-time application on Apache Beam. It's running on Dataflow. And its main responsibility is just reading the events from Kinesis and streaming it to BigQuery. So this has been covered by Karti, but at the moment we are using streaming approach only. That way, all the data from our systems, the data is available in our lake in a matter of seconds. Why we decided to run event processing on Dataflow? To be honest, at the very beginning, we tried Spark streaming. It was working pretty well, but we had two main issues. So first of all, we had problems with HA. So basically what to do if your workers are failing or master node is failing, and especially what to do to make sure that in case of failure, we are not losing any events. And secondly, we needed autoscaling. Our workload varies. So at some point, we are sending thousands of events per minute, a little bit later, hundreds of thousands. And those problems have been solved by Dataflow for us. As mentioned before, we are using structured data. And to have a good control over what we are sending to our lake, we introduced another component, which we call data registry. It's App Engine application in which every type of the event that enters our system must be registered. By register, I mean the user needs to define the schema. So what are the fields inside this event? Those fields are mapped into columns in BigQuery tables. What are the data types? And some metadata information, like event name, event group, which we used to route this event into particular location in our data lake. This is also our data governance tool, because every single piece of information that enters our data lake is stored here. So basically, you can run some text search to see where your data, from where it's sent and where it is routed in BigQuery. So let's talk about our data model. So as mentioned, we have our events, which we call raw events. And what is important, this is the private area for the team that is producing this particular piece of information. No one else in organization is allowed to read raw events, which are basically mapped to BigQuery tables. To expose this data to the rest of the organization, we created a kind of data level API. So we introduced so-called data objects and derived objects. So for creation of the data objects, in most cases, this is just a view or physical table that is refreshed a couple of times a day, are responsible data producers, so teams that are producing this information. So basically, this is how we enable the whole organization data processing. So teams are responsible for creating the views. The views are combining those information from microservices by doing unions, joins, the duplication, aggregation, whatever makes sense, to create a kind of business entity, meaningful business entity. To do that, we run quite a lot of workshops to show people how to use BigQuery, demonstrate some most important aspects of BigQuery, and teach them how to process the data in general. So data object and derived object are quite similar. The main difference is that the derived object may blend data from multiple systems. For example, order management data with payments data. So this is a kind of data mart that fits some specific business purpose. And derived objects we are sometimes exporting to Google Cloud Storage, and this is how we make it available for our retailers to be downloaded and analyzed. So just to sum up, events, this is private implementation of our data, internal API, data objects. So this is how we are exposing the data internally, and external API, derive object. They are also shared with retailers we work with. To do this transformation from raw events to data object and to derived object, we needed a kind of workflow scheduler orchestration engine. And a couple of years ago, we couldn't find anything that satisfied our needs. So we created our own solution. We call it Query Manager. So this is the application where you can create tasks like execute a query, create a view, extract some data to Google storage. You can combine those tasks in workflows and schedule them. But at the moment, there is a new component in Google Cloud called Google Cloud Composite, and it basically solves the similar business problem. So it's a workflow orchestration engine. OK, so we have 3 levels of data classification. First is the type of the object that I have mentioned, so raw events, data objects, and derived objects. Second is business or subject area. So what is the content in this particular table? And we figure out a number of areas. This is just the sample with sub-areas. So we classify all our data that way. So for example, if you would like to take a look on some payment information, you can find them in the area payment details. And the third level of classification relates to security. We have 3 levels. Public, so this is a kind of data that can be open sourced. At the moment, we are not doing that, but the platform is ready for that. Second level is restricted, so everyone in the organization should have access to this data if needed, and confidential. This is a little bit more secured. That's because this kind of information may contain some sensitive information, like PII data of our customers. And combining those 3 classifications together, we created a convention how we are naming our data sets. So dataset in BigQuery is an aggregation of DB objects, views and tables. And it has been mentioned by Dhaval, but just me repeat, you grant accesses on dataset level. So basically, you grant access to every single table and view there is in this particular dataset. So that's why, let's take a look on the example. For example, the second dataset. Order details, it means that we have information about orders there. Data, it's not derived, so the information are not blended with different systems. It's purely about orders, and restricted. So no PII inside, everyone in the organization can use it. So this is how, by just taking a look on the name of the dataset, you know more or less what is inside. Yeah, so this is basically how we are governing our data, how we are loading the data to our lake, and how we are controlling that and transforming our data. If you are interested in building data lakes on GCP, I would recommend taking a look on materials linked here. For example, article or some quick start guides. If you are not very familiar with BigQuery, there is quite a lot of resources, Coursera self-study. It's a lot of materials. There are also some related sessions during this conference. So if this is something that interests you, I would recommend to join them. Just letting you know that my colleagues from Ocado are also delivering 2 sessions. So if you are interested, for example, how we are doing machine learning, just after lunch there is 1 session about building our cloud ML infrastructure. And on Thursday there's another, how we use AI to leverage retail business. So that's basically all. Thank you. It was a pleasure to have a chance to talk to you.